Greetings and welcome, friends. Today we are continuing our lesson on solving multi-step equations. These ones are going to be more complicated than you saw yesterday. These are the boss fight problems that combine all of your skills of punch, kick, and block, of distribution, combining like terms, and solving equations using inverse operations. So here we go. This problem's for real, friends. Actually, For Real Friends were a series of stuffed animals, I think, that came out back in like the early 2000s. But that is not what I'm talking about today. I'm talking about solving multi-step equations. So here we go. Before I start solving, I've got to simplify both sides. So we're going to do what's called the distribution property. This 2 on the outside is being multiplied by this parentheses, and we are able to multiply it into everything on the inside of the parentheses. Notice plus 3, you're not in the parentheses, you don't get the 2. So let's multiply this through. Distributive property only applies when you're multiplying over addition or subtraction. So 2 times 1 is 2. 2 times negative x is negative 2x. By the way, an x always has a 1 as its coefficient if it's not written. So I did 2 times negative 1 and got negative 2. The parentheses disappear now that I've distributed. And the plus 3 is still hanging out here. This equal sign is still here. This negative 8 is still there. And I'm actually not done simplifying. I'm done my distributing step, but not simplifying. I've got some like terms to combine. Are there any other x's that I can combine on this side of the equal sign? No, negative 2x has nobody to combine with. But the constants I can combine, I've got a positive 2 and a positive 3. That I'll combine. So when I write this, I like to write my x's first, so I'll write negative 2x. Then I've got 2 plus 3 is positive 5 equals, right, negative 8. And now that I've simplified, so here's like, I guess, our general process. 1, simplify. Man. Please start writing for me, tablet. You're hurting me today. And step 2 is SAD map, right? Do inverse operations in the reverse order to get the variable by itself. So which should I deal with first? Multiplying by negative 2 or adding 5? Thoughts? What should I deal with first? The 5, right? And the inverse of adding 5 is to subtract 5 from both sides. Notice when I do this, I write the minus 5 step right underneath its like term. So these 5s cancel out. I'm left with negative 2x on the LHS, the left-hand side. Equal sign, keep them in a column. And negative 8 and negative 5 becomes more negative. So 8 plus 5 is 13. And they keep their sign of negative, right? Right. Wow, this one's going to have a fraction answer, friends, but fractions exist in the world of math and in real life, actually. I don't know if you knew that. It's true. So let's see, negative 2 times x, the inverse operation of multiplication here is division. By the way, super common mistake. Here's the wrong way. Some students will see this minus 2 and then be like, oh, I just got to add 2. That is not subtraction. That is not minus. That is negative. All right. So the inverse, the operation that was happening was multiplication. So the inverse is division. Division. So I'm dividing both sides by negative 2. I will get x equals negative divided by negative is positive, and 13 halves is an irreducible fraction. Man. So there we go. X equals 13 halves is your answer. I'm a fan of leaving our answers as improper fractions. So that's what I would recommend. But theoretically, yeah, you could write that as a decimal as 6.5 or something to that effect. Is that going to work out? Guys, did I make a mistake anywhere? Let's see. 2, negative 2x, 3, 2 and 3, 5, minus 5. Right, yeah, 13. Well, let's do a check and see what happens here. Do a check. Check it. Check. So I'm unsure. Okay. Actually, I think this will. Okay, the doubling will take care of it. Let's see. So I'll have 2 times 1 minus 13 halves, parentheses, plus 3. Is that equal to -8? So 1 minus 13 halves. You could rewrite 1 as what fraction that has the same denominator? You guys remember adding and subtracting fractions? Most people have a hard time with it. I'd have to multiply this by 2 over 2. So 2 halves minus 13 halves. I subtract the numerators, 2 minus 13. I know, this is crazy, guys. This is a scary, scary problem. 2 minus 13 is going to be -11 halves plus 3 equals -8. Now, when I multiply these, 2's cancel out. I just get -11 plus 3 equals -8. And -11 plus 3 is, in fact, -8. So it does check out like so. So it did work out. 13 halves was the correct answer, or positive 6.5 also works. Let's see. Let's look at another example here for you. Ooh, I like this one. Another example coming your way. Zippity-doo-dah, zippity-day. All right, here we go. Here's another solved problem for us. But the first thing I do before I solve is simplify. Simplify. So I'm going to distribute. This is multiplying right here and here. So 2x times 5. Well, 5 times 2x, I would multiply 5 times 2 and I'd get 10x. All right. 2x times -3 is -6. This -3x was not included because it was outside the parentheses, but it still is in the problem. So -3x equals 5. Combine like terms. I've got, oh, guys, I made a mistake. Where's my mistake? Right here. What's my mistake? It needs an x. Yeah, thank you. Wow. 2x times -3. 2 times -3 is -6. But where'd that x go? That x is still hanging out. There, right there. So when I combine like terms, I'm going to take this, 10x's, minus 6x's, minus 3x's. Man, someone's taken away all my x's. 10 minus 6 is 4. 4 minus 3 is 1. I've got 1x left. But I don't even have to write that 1. And hey, wow, look at that. The problem is solved. It's solved. The simplifying did it for me. I didn't even have to use inverse operations. Hooray! Celebrate, everybody. Hooray! Let's see. Let's do one more. Here's a crazy sauce problem. All right. And then we're going to do a problem with words in it. That's right. Whoa, here's the crazy sauce. What? All right. Here we've got 2 sets of parentheses. And we're going to do some distributing here. So I do actually see an alternative method for this problem, but we'll just do the distributing one. I view this as positive 2, by the way. If that was a minus sign there, I'd have to include the minus sign in that multiplication. So let's see, 5 times 3, 15. Help me not make a mistake today. 5 times -x is -5x. 2 times 3, positive 6. 2 times -x, -2x. Did I make a mistake? You guys with me? I'm making these mistakes on the internet. I need you to help me out if I'm doing it wrong. All right, I think I'm good. Combining like terms. Do I have some x friends here? Yeah. And those actually do include their signs with those coefficients. So that's -5x, -2x, and any other friends that I can combine. I think the 15 and the positive 6 are like terms. Neither of them have variables. They're both, we call those constants. So those are like terms. Can I combine the 14 with those? No. Why? I like it, man. Guys, we're going to be professional algebraticians by the end of this. I love it. So 14's on the other side of the equal sign. Eventually, I'll be able to combine these with it once I move them, when I subtract them from both sides, as we'll see momentarily. So negative 5x's plus negative 2x's is negative 7x. 15 plus 6, positive 21. Equal signs, line them up, equals 14. And now, here's a classic two-step algebra problem, right? So far, the first thing I did simplifying, I did distributed, and simplifying by combining like terms. Now that my simplification is out of the way, now I'm solving. So, to solve, do I deal with the negative 7 or the plus 21 first? Plus 21, because the negative 7 is actually multiplication by the x. I want to deal with the addition. I'm sad mapping. So sad map, disassemble, dead. Here we go, minus 21 from both sides. Whoop, whoop. And oh boy, these 21s cancel out. That's exactly what we wanted. X is becoming more and more lonely as the days go on. It just lost its friend 21, but it's still holding close to its negative 7. Let's see, we've got 14 minus 21. Oh dude, signs are different. So I subtract the numbers in any order I want. So I'm going to do just like 21 minus 14 in my head. What's that? 21 minus 14. Anybody? 7. I like it. All right, so 21 minus 14 is 7. And I take the sign of the more influential because their signs were different. Who was more influential between this guy and this guy? The 21, so it's a negative 7. Okay, so x, you're going to lose your last friend here. Look out. X is being multiplied by negative 7. Don't try to add 7 to both sides. I see how tempting that is. X is not being added to by 7. It's being multiplied by negative 7. So the inverse of multiplication is division. I will divide both sides by negativo 7, mis amigos. And the 7s cancel out. The minus signs cancel out. X is all by itself, singled out. 7 divided by 7 is 1. Negative divided by negative is positive. X equals uno. Wow, mis amigos, excelente. We did it. We did it. I like it a lot. Let's see. Let's do one. Oh, that word problem's not that impressive. Okay, here we go. Here's a real word problem. Solving a real life problem. Because yeah, algebra was invented to solve problems. Algebra actually comes from Middle Eastern Arabic cultures. It was discovered by Arabic mathematicians back in the day. I mean, algebra, that sounds very Arabic, right? It was actually invented or / discovered as a means to distribute inheritance among children. Yeah, who would have thought? So here we go, solving a real life problem. So now you guys won't have an opportunity to write all of this down. That's fine. It's also example 5 in your book, probably somewhere around page 15, maybe, I'm guessing. So it says your school's drama club charges $4 per person for admission to a play. The club borrowed $400. Ooh, borrowed. What operation does borrowed sound like? I would think subtraction, right? Like that sounds like they're losing money here. But we'll see how we set this up. That might not be what we need to do. To pay for costumes and props. After paying back the loan, the club has a profit, sounds like positive, $100. How many people attended the play? Now, I have not shown you all of these strategies yet. Let's see, what color should I do this in? I'll do it in yellow. Now, when we're solving a word problem, okay, there's a lot of information going on here. You might be like, I don't know, maybe I can guess the answer. Actually, this one you might be able to. You done might be able to. But I'm going to give you a process to help us do this. The first thing I'm going to do is define a variable. And variable That's the thing that we don't know. That's the thing that I'm trying to answer. Okay, like 95% of the time, your variable is going to be the question they're asking. How many people attended the play? So I'm going to come up with a variable. So that's a letter. What's a good letter I could choose to represent this? Could just be X. We could be generic mathematicians. Let's do, I don't know, P for people, or yeah, person. So let's let P equal, what does P represent in this problem? The number of people who attended the play. Does that make sense? The thing that I solve for will be the thing that answers the question, and so P is going to be the number of people who attended the play, or who attended. All right, so the better that I can define my variable, the more sense this problem will make to me. So the first thing I do is V, variable. The next thing I do is I write an equation. So this is where I combine the hints that the problem has given me to be able to like represent this situation. Okay? So there's a few different ways we could write this equation. The equation is going to be written from the clues of the problem and in terms of the variable. So let's see. It says the school's drama club charges $4 per person. So that $4, if I wanted to figure out how much money they made from tickets, not profit, but just the revenue, how much money came in from tickets, what would I do with the 4 and the number of people who attended to figure out how much money came in from selling tickets? Anyone have a guess? $4 per person. If I multiply this by the number of people, the per person would cancel out with people, and I'd be left with money that came in from that number of people. All right, so I'm going to have 4 times P. All right, and this term represents, I'll actually even write this out, money from ticket sales is what that term represents, right? $4 per person times the number of people will give me the money I made from the tickets. But they didn't get to keep all that money. We lost money. What did we lose? We borrowed $400. So we've got to, from that number, we got to subtract $400. So here's the money that we had come in, the money that we had to pay. So we lost $400. And that should equal the money we have left over, which we called profit. So equals $100. So the money that came in minus the money that we spent equals the money we have left. That makes sense so far? And understand it's going to take some practice to get familiar with these. It's okay. I just want to get us set up. So this is right, the equation step. So VE. Next step is S for solve. This is where we're going to answer the question. So I'm going to just rewrite the problem. So 4P minus 400 equals 100. You guys know how to solve, right? We're master algebraticians already, right? This is the hard part for you guys, right? This is the thing that's going to take training. This is the skill that I've already shown you. So let's see. If I want to solve for this variable, what do I move first? What do I get rid of? What inverse operation do I need to do? Thoughts? Add 400 to both sides. I agree. I concur. So let's see. Those 400s cancel out. I'll get 4P equals 100 plus 400 is 500. And now what do I do to solve? Okay, thank you. All right, thank you kindly. So guys, how do I get rid of the 4 in front of the P? That is being multiplied by P. So I've got to divide by 4. You guys, you're getting it. You're getting it. So let's see, divide by 4. 500 divided by 4. I understand you might reach for a calculator for that one. I could kind of see that. But let's see, P equals, well, 4 would have gone into 500. Well, let's see, 4 goes into 400 10 times, and then 4 would go into the remaining 100. What's 100 divided by 4? 25, like 4 quarters in a dollar. So the way I'm thinking about this in my head is I'm thinking of 400 plus 100 all divided by 4. And I'm like, well, that's the same as this divided by 4 plus that divided by 4. And I'm like, this is 100 times, right? Because you just, right, that's just 100. And then 100 divided by 4, like a dollar divided by 4, it's 4 quarters in the dollar. So what do you think 500 divided by 4 is? 125. Now, I solved the equation, but if I ask you a question, like a random question, then you respond P equals 125, I don't know what that means. All right, we got to bring it back in context of the problem. This is a word problem, and word problems, I know we're mathematicians here, but word problems need word answers. So this is the A part of the problem solving plan. And to write your answer, the way you do this is combine B and S. Watch this. This practically writes itself. This is how a mathematician writes a sentence. Let's see. So variable, I said P is the number of people who attended. So I'm going to take this phrase, and I'm going to combine that with this solution. So this sentence is going to write itself. Watch this. My answer is 100. Well, I'll write it out. 125 people attended. Look at that. Like super straightforward. I just combine my definition of my variable and the solution of my variable, and I just plug them together, and I'm done. All right, well, thank you for watching, internet friends. Tienen un día el más bien del mundo. Bye-bye.